welcome to Session 2 of Teradyne's Virtual Technical Interchange Meeting 2021. My name is Rob Quinlan, and I'm an Applications Engineer in Teradyne's Mil-Aero division. It is my pleasure to join with you today to demonstrate the process of converting M9-Series TTB files to DI-Series DTXT files using iStudio's Digital Test Editor. Many users have invested time and money in developing digital test programs using the M9-Series soft front panel and saved as M9-Series DTB files. The Digital Test Editor's import and export tools provide users who are upgrading from M9-Series hardware to DI-Series hardware a simplified solution for migrating their test programs to the DI-Series product, allowing them to maintain and develop their programs using iStudio and the Digital Test Editor. The process steps for converting a DTB file to a DTXT file are as follows.
First, we will create an iStudio project. Then, we will create an Express Services configuration database for our test system. After that, we create a new digital test to add to our iStudio project. We will then import our DTB to the new digital test using the Digital Test Editor's import tool. Once the digital test is imported, we will execute and debug the digital test using the DTE. When we are finished debugging, we will export the digital test as data. This will export the digital test data as a DTXT file. With the DTXT file in hand, we will move over to Test Studio, where we will execute the DTXT using the Express Services Digital Test add-in. We will then go over the process of exporting a digital test to ANSI C and using the exported C file to build a console application that will run the digital test. After the demonstration, there will be a live Q&A session where I will be joined with other Teradyne experts to answer any questions you may have. Now, without any further ado, let us begin. First, we will need to create an iStudio project for us to save our work in. You can open iStudio from the desktop icon there, or by going to Start, navigating to the Teradyne Launcher, opening the Teradyne Launcher, navigating to iStudio and expanding it by double-clicking, and then double-clicking the iStudio icon. This will bring you to the iStudio homepage. Once iStudio is opened, we will need to create a new project. Create a new project by clicking the New Project icon in the toolbar, or selecting File, New Project. This will display the New Project Properties page. Fill in the fields for the project name and directory. If you would like to set the directory as default, you can do so by checking the checkbox below. Select a tag from the drop-down menu if you wish to assign a tag to the project. This is optional. In the Simulation section, click the Enabled checkbox to enable simulation mode. The directory box displays the path to the directory where the automatically generated simulation configuration file will be located. The Express section displays the names to be assigned to the Express databases upon creation. If you have existing configuration and PinMap databases for your test system in UUT, you can specify those files here. Today we will be starting with new databases that we will then populate. Once you are good to go with your project and database names, click OK to create your new project. The new project will open in iStudio, and you will see the project name in the root of the tree pane on the left. And in the project window, you will see project info at the top that provides a section for users to add a description to their project. Below that is the Express Databases and Test sections. The Express Database section is populated with the files that were created or selected during project creation. Since we haven't added any tests to our project, the Test section is currently empty. We are now going to set up our test system configuration database. Open the configuration database by clicking the link labeled Configuration in the Express section. This will open the Express Services Database Editor. There are two ways you can populate your test system configuration database. First, you can automatically populate using the Express Services Hardware Configuration tool. Alternatively, you can manually add them within the Express Services Database Editor. First, we will cover the automatic method using the Hardware Configuration tool. Before running this tool, ensure you are connected to your test system and NI-VXI Resource Manager has been run. The hardware configuration tool can be found from the Tools menu in the Express Services editor. When you select the hardware configuration tool, the hardware configuration dialog box appears. Fill in the fields for the database name, test system name, and test system location. When you are satisfied with your names and location, click Run, and wait while the config tool determines what instruments and drivers are installed on the test system. The tool will issue a warning if a driver is found for which there is no instrument, and an error if an instrument is found for which there is no driver. After the tool has finished running, the Update Project button will become enabled. Review the output to verify your instruments were found, then click Update Project to populate the database with the instruments found. We can see that instruments have been added to my database. You see at the top there are 5 DI modules, as well as SCIPM and Power Supply instruments that are also installed on the system. Now that my configuration database is populated with my instruments, I am going to run validation. Validation verifies that the drivers and instruments defined in the configuration database are available and that the wiring required to access the capabilities defined in the PinMap database is complete. Each database is validated individually in the following order: configuration, receiver, PinMap. You can see that validation has passed, as indicated by the green checks next to all of the nodes in the tree pane. You can also view the validation results in the output window. Next, we will look at manually populating the Express database. Starting with a new Express configuration file, I pull up the context menu for the VXI test system node, select Add Instrument, and then select the instrument that I want to add. In this case, it is the Gen 2 high voltage model. When manually populating the configuration database, you'll also need to assign location attributes in the instrument's properties. Type in a location descriptor in the Identity section, then fill in the location attributes section with the appropriate values for the hardware you are adding. Validation will fail if this step is omitted or if the location attributes do not match what is installed in the system. When you are finished adding instruments to your configuration, save, then validate the project. With your instruments added and the configuration passing validation, we are now good to exit the Express Database Editor and return to our iStudio project homepage. Next, we will add a new digital test to our iStudio project. First, highlight the project's root node in the tree pane, then add a new digital test by either clicking New Test from the toolbar, then selecting Digital Test from the Test menu in the menu bar here, or going to the context menu of the project node in the tree pane and selecting New Test, Digital Test. After selecting Digital Test, a new node will appear in the iStudio project tree, and the Digital Test Editor will open to the newly created Digital Test. From here, we're going to import our DTB. To do this, open the DTB Importer dialog box by selecting Tools, Import, DTB, then click the ellipsis to browse and select your DTB file. For today's demonstration, I will be using an example DTB file that is installed with the M9 driver. This example DTB I am using, loopbackDynamicTest.dtb, performs a loopback test between channels 2 and 3, as well as 4 and 5. The test simply drives a logic low and high out of channel 2 and expects a low and high on channel 3. The same is done for channels 4 and 5. The test will pass when wires are connected between channels 2 and 3 and 4 and 5. In the UUT name dropdown, select Create New and fill in the text box below with the name of your UUT. If you have a UUT already wired in your PinMap database, you can select that UUT from the dropdown. Finally, select your target instrument from the drop-down menu. When you are satisfied with your selections, click Import. If the DTBs you are importing are large, it may take some time to complete. Upon completion, the output window will report any problems that occur during the import, and errors can be found in the Errors List window. The Error List window will also report informational data about features that are in the DTB file but are not supported by the DTE. Now that we have successfully imported our DTB file, we are going to execute the test from the DTE to ensure that everything works as expected. There are a number of ways to execute the test program from the DTE. You can select the play icon from the toolbar here. You can go to the Run menu in the menu bar, select Execute, or simply press F5. The pattern set will first be validated to verify that no program properties have been violated. The executable source will then be built in the test run. Note at the bottom the resource string that configures the instrument. The two numbers to the right of the resource string are the number of patterns and total signals. The status of the executed digital test can be seen in the output window. You can see that my test has passed here. You can also see the status of the test by looking at the pattern viewer and looking for a green or red icon next to the pattern set indicating pass or fail. I am now going to disconnect one of the loopback connections and rerun the test so you can see what a failing test looks like from the pattern viewer. I've disconnected loopback between channels 4 and 5, and now I'm running the test again. As I expected, the test now fails. A review of the pattern set viewer indicates that channel 5 failed to monitor high on pattern 1. And sure enough, that is the connection that I broke. I am now going to reconnect those channels and run the test one more time, verify that it passes before I save and export the test. Open the Export Data dialog box by selecting Tools, Export, and then Data. In the Export Data dialog box, select the path and name of the DTXD file to be created. There are two optional checkboxes, allowing users to choose to use an index-based resource string or to create pins using their channel number. In the Language Selection section, select either ANSI C or C#. The language selection determines what template code is exported along with the DTXD. The template code provides functions that allow a user to execute the DTXD using the API. When you are finished with your selections, click Export, and the test will be validated and written to the folder specified. At this point, our DTB has now been converted to a DTXD file. We can verify the export was successful by viewing the output window. Next up is executing the DTXD file from a teststudio environment. Save your project in the DTE, then exit. Do the same in iStudio. If you do not already have a teststudio project to work from, you will need to create one. Open teststudio either through the desktop shortcut or through the Teradyne launcher, found in the Start menu. Depending on how teststudio is configured on your system, you may be prompted to log in. Do so if prompted. Once logged in, you will be brought to the teststudio homepage. To create a new project, you can either click the Create New Project link from the homepage, click the new icon from the toolbar, or select File, New. This will bring you to the New Component page. Select Project, and the New Project page will be displayed. Give a name to your project, and choose the destination for your project folder to be saved. I am choosing the same directory as the iStudio project from earlier. There are two additional options for specifying the project file name and the execution folder. I'm going to leave those as default. Next, select Execution as the tree type. Then, give a name to the tree and to the Trees tab. Finally, select with Express Services from the Project Template drop-down menu. Then click Create. teststudio will take a few seconds to set up the new project. When it is finished, a Configure Express Services Database Files dialog box will appear. For each database file, click the ellipsis next to the text box navigate to and select the Express database file that was generated from the iStudio project when converting the DTB. If you recall, I saved the TestStudio project in the same folder as the iStudio project, which makes it very easy for finding the databases, as they will be the first thing to appear when I click the ellipse. When you're done selecting your Express databases, click OK. The Configure Databases dialog box will go away, and the project databases will be configured. After a quick save, it is time to move on to adding and configuring a node to the project. To do this, we right-click the root node and select Edit, Insert Child. A new unconfigured node appears below the root. Give a name to the new node, then open the context menu and expand Applets, Express, Digital Test, DI-Series Digital Test. The Express Digital Test add-in can be configured as an inlet, leaflet, or outlet. I will be configuring it as a leaflet today. After selecting the leaflet add-in, the applet confirmation page appears. Click OK to bring up the DI-Series Digital Test setup page. Click the folder next to the DTXT file name text box, then locate the DTXT file you wish to execute. If you have an alignment value file you wish to apply, check the checkbox and specify the alignment file in the box below. Check the boxes for Reset on Init, Reset on Close, Program Digital Relays, Program Hybrid Relays, as needed. If digital or hybrid channels are used in your digital test, the respective box must be checked here for the test to function properly. This example does not use hybrid channels, so I have left that unchecked. When you are satisfied with your setup selection, select Apply or OK to commit the changes. Neither Apply or OK will save the project, as indicated by the asterisk at the top. Now I'm going to save the project and execute the digital test. The project can be ran from the project status page by clicking Run Node from the play icon in the toolbar here, or by selecting Run All from the execution menu here. After running the node, we wait for the test to finish and hope to see a pass on the status page. And there we have it. We have gone through the entire process of converting a DTB file to a DTXT file using iStudio's digital test editor, then executing that DTXT file in Teradyne's TestStudio environment. I will now demonstrate how to export a digital test to ANSI C and how to use the generated C file to execute the digital test. I am now back in the digital test editor with my digital test from earlier loaded. To export to ANSI C, I select Tools, Export, ANSI C, and the Export ANSI C dialog box appears. Select the destination and file name for your export C code, and check the boxes if you wish to use an index-based resource string or to create pins using channel numbers. When you are satisfied with your selections, click Export and the DTE will begin the export. Check the output window to verify there were no errors. There were none here, so now we will go look at the generated C file. Here I have the exported C file, Digital Test C, open in a Visual Studio solution. A quick look inside the code and we see three methods provided that allow you to run the digital test. First, execute by instrument, where you pass the instrument handle to the function. This requires that you initialize the instrument to retrieve the instrument handle. Second, execute by resource name, where you pass the resource string to the function. This requires that you know the resource string needed to configure the instrument. Third is execute, where you pass nothing. This uses the same instrument resource as used to develop the digital test. Note that the function names include the file name defined for the exported file, digital test in this case. If a different file name had been used, dynamic test for example, then the prefix digital test would be replaced with dynamic test, resulting in new function names. Also in the solution is a main.c file that calls the provided functions in the exported digital test C file. Note that in this example, the enumeration method defines which function is used to run the digital test. If the method is set to 1, then we define, initialize, and reset the virtual instrument. If the method is 2, then we simply define the virtual instrument, and the digital test program will initialize and reset the virtual instrument. If the method is 3, then we let the exported digital test define, initialize, and reset the virtual instrument. Note that we can only get pass-fail information back from the exported digital test. To get more information will require us to add code to the calling routine, the exported code, or both in the form of DI-series IVC API functions or C# methods, depending on which export was used. I am now building the executable to run our exported digital test. When it is done building, I will run the exe from Visual Studio to ensure everything passes. Now that the test executable has finished and the test passed, we are finished. This concludes the demonstration portion of today's TIM session. Thank you for joining us, and please stick around for a live Q&A session.
Hello, everyone. Thanks for joining us today. I'm Tara Marchetti. I'm an engineering manager here at Teradyne, and I'm here to pass along your questions to Rob. So if you have any questions on today's presentation, please add them to the chat for this live event. And Rob, thank you for being here. Thank you for taking the time to do this.
Yeah, of course. Hi, Tara. Hi, everybody else. Thanks for having me. Happy to be here.
Great. So as we wait for some questions to come in here, I have a question to get us started, something that I know I've heard asked before. You mentioned that we start with new Express databases before creating a test in the digital test editor that will be populated, and you demonstrated populating the configuration database. What about the receiver and the pin map?
Yeah, of course. The receiver and pin map databases will be populated by the digital test editor when the DTB is imported.
Okay, and so how does the digital test editor know which channels to use for wiring?
So the digital test editor will use the same channels that were used for the M9. So as long as the wiring and the channel numbers are the same when you're going to the DIs, that should be just fine. Users will have to manually change the wiring if they are using different channels on their DI system.
Okay, that makes sense. We converted a DTXD to a DI-DTB file for this demonstration. Can you explain why someone would want to do that? Because you can run a DTB file through the M9 interface, correct?
Yes, you can also run through the M9 interface, but because you're using a test defined in the DTB in a test program that might want to take advantage of new DI series features, you don't want to mix the M9 and DI series API calls.
Okay, so to use DI features, you could convert from the DTXT to DTB and now take advantage of some of the new features, right? Is that right?
Absolutely.
Right. Once you got into Test Studio, during the digital test setup, you checked all the boxes except for the hybrid relay option. Why didn't you select the last option, or when would someone want to select that? Or not check the other ones as well?
So the test that I had demonstrated was a very simple test, and it only used the regular channel connections. It wasn't using any hybrid channel or hybrid relays. Therefore, I didn't need to give the programming of those hybrid relays over to Test Studio or to the program there. As for the reset on init, reset on close, and the programming of the regular channel relays, sometimes, well, those 4 boxes will exist to avoid interfering with other tests that may be going on. If the digital test is part of a larger project where the instrument has already been set up for testing, switching some relays or resetting the instruments might affect those other tests. So again, those exist to avoid interfering with other tests that may be taking place.
Great. All right, I am taking a look at the chat here, Rob. I'm not seeing anything coming in. I guess it was just such a clear presentation that we don't have any open questions. So I think that concludes the event for today. Again, thank you for taking the time, Rob. Thank you for everyone who joined us today. And we hope that you'll join us for our next Teradyne Live event.
Thank you.